Okay, let us focus on this question. We have the following question. It says, assume a memory access to main memory on a cache miss, which takes about 30 nanoseconds. And we would like to, the question asks us to compare the following caches in terms of average memory access time. Okay? So the first question says cache hit memory access time of 4 nanoseconds with a cache hit ratio of 80%. How do we approach this problem? You're here, okay? You're here. You want to access the main memory, right? Here is main memory. And there is a cache in between, right? Cache. And you have to access main memory, so you have to go through the cache. Okay? If it is there, you get your response. Okay? And that sometimes takes 4 nanoseconds. So in this question, it takes 4 nanoseconds. In this question, it takes 5 nanoseconds. In this question, 8 nanoseconds. So you have to try all of them with this varying degrees of probability. We'll come to that later. So it takes, let's suppose it takes 4 nanoseconds. If it is in there. If it is not in there, you have to go back to main memory, get the picture, get the data, whatever that data is, into cache first, and then forward that data to the user. Okay, user is here. Okay. So what does that take? Go through the main memory. It takes 30 nanoseconds. Okay. Sometimes it says accessing from cache to memory takes 25 seconds or 30 nanoseconds. Unless it's specified like that, we will take this 30 nanoseconds to be the round trip time of the user data, which accesses the main memory as well as cache. So you go through these hierarchy with 30 nanoseconds. If it fails, okay, with the cache. So coming back to our question is asking average memory access time. Okay. So you can think of this A as being average, or not the average, but memory access time, let's say, memory access time. Okay, then we're actually interested in expectation of this memory access time. And as you can guess, this is going to be AAPA. In other words, you basically sum over all A's, okay, the following quantity, A dot PA. What is A? What is PA? Well, A is all possible, different types of possibilities, right? But in that case, we are looking at the access time. So we have to sort out all these possibilities first, okay? The probability distribution as well as the what these probability distributions are. In other words, what those probability distributions correspond to. In other words, let's think about the possibilities. You can have cache hit. Okay, so let's suppose C is cache hit if it is 1, okay, and cache miss if it is 0. And we have M, let's say, this is memory or main memory. Okay, main memory hit if it is 1, and memory miss if it is 0. Okay, so let's just sort out all possibilities in here. We have C equals let's say 1 and memory is 0, okay? We have C equals 1, memory equals 1, right? C equals 0, memory equals 0, and C equals memory is equal, and C equals 0, memory equals 1. So if C is 1, that is cache hit, and memory equals 0, okay? Which is usually not possible, by the way, because if you've got a cache hit, that means a copy must be in the lower level of the hierarchy, which means this probability is 0. Okay, if it is cache hit, you got as C1 and M1. Okay, that is the case that we're talking about in this picture. It says cache hit memory access time of 4 nanoseconds. Okay, it takes 4 nanoseconds in this case. Okay, takes 4 nanoseconds, but that happens with probability 0.8. Okay, so these are probabilities. Okay, all right, and but also we have to write down what the cost is, right? Say this is cost. So the cost, this is 0. Whatever that cost is doesn't matter. Let's say just use question mark because it's not given in the question. Okay, what is the cost of this? It's 4 nanoseconds. 0, 0 means there's nothing in the memory hierarchy. Okay. That is also not possible because our main memory is the last level of hierarchy. Data must be there, otherwise, we're not dealing with anything. So which means that also happens with zero probability. And what's the cost? We don't know. And finally, we have C0 and M1, which means the cache miss scenario. In that case, this happens with 0.2, right? Because if it happens with 0.8 hit, then this must be 0.2 because these are all possibilities and it has to sum to 1, right? This probability. And what's the cost of this? Let's suppose it's 30 nanoseconds. Okay? All right? So finally, the answer to this, our average access time, is applying the formula. We have this A is our cost, and what is the probability of these costs? The probabilities are given by these numbers. So it's 4 multiplied by 0.8 plus 30 multiplied by 0.2. Okay? Which gives you 3.2 here and 6 here. Okay? Which is 9.2 nanoseconds.